Good morning. So today we're starting our final unit for Algebra 1. It's Unit 11 on radicals. If you'll notice, it says Lesson 11.3. That's where we're starting. That's because the first two lessons have to do with the real number system, and we had already talked about that back in the first semester. All right, so we're going to start out with some terms like the word square. It says the product of a number in itself. The product of 6 and 6 is 36. 6 squared is 36. Square root, one of two equal factors of a number. For example, the square root of 9 is 3 because 3 times 3 is 9. The radical sign, that's the symbol, is used to indicate the square root of a number. A perfect square is a number whose square root is a whole number. Example, 16 is a perfect square because the square root of 16 is 4. 4 is a whole number, not a decimal or a fraction. Okay? Squares and square roots. How to square a number. To square a number, just multiply it by itself. For example, 3 squared means 3 times 3 or 9. Here's a visual, and it broke a square into 9 equal squares to show you that 3 units times 3 units gives you 9 units. All right, perfect squares are squares of whole numbers. So you're filling in whole there. I think we've already done a perfect squares through 20, but I'm just going to put them back here so you all have them in front of you. And I'm not going to fill the whole chart out. So 4 squared, I'm not going to do it in expanded form, is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared equals 64, 9 squared equals 81, 10 squared equals 100. That's the first 10. Let's do 11 through 20. 11 squared is 121, 12 squared is 144, 13 squared is 169, 14 squared is 196, 15 squared is 225, 16 squared equals 256, 17 squared equals 289, 18 squared equals 324, 19 squared equals 361, and 20 squared equals 400. Okay. So, like I said, you probably already know most of these to memory, but if you don't, it's a good idea to try to learn them. But if not, you have this chart to look at, because what we're going to be doing is when we simplify radicals is we're going to be looking for perfect square factors that we can take out to help us simplify. Okay, I think you're on the next page now, and it says square roots. It goes the other way. So 3 squared meant 3 times 3 is 9, but the square root of 9 means it equals 3. A radical with this symbol is used to show a number's square root. The radical is used to write the principal or positive square root of a positive number. The square root of 49 equals 7 is read the positive square root of 49 equals 7. I usually just read it as the square root of 49 equals 7, assuming we know it's a positive. The negative square root of 49 equals negative 7 is read the negative square root of 49 equals negative 7. In the expression, the square root of 49, the number inside the radical is called the radicand. So 49 is the radicand of the square root of 49. There's a couple properties here that they're just reminding us of that helps us when we simplify. Every positive real number a has 2 square roots. Okay, the square root of a and the negative square root of a. The symbol, the square root of a, denotes the principal square root of a. 0 has only 1 square root, namely itself. The square root of 0 is 0. There's not a positive and negative square root of 0. Okay, then there's the product property of square roots. For any non-negative real number a and b, the square root of a times b, we can separate into 2 factors, the square root of a times the square root of b, and we'll be doing that in a little bit, and you'll see how we use that property. The quotient property, which is missing a y, of square roots says for any non-negative real number a and any positive real number b, the square root of a divided by b can be separated to the square root of a over the square root of b. And there would be a reason why we want to do that. If we can easily square one of them because they're perfect squares, we would separate that radical. All right, let's do some practicing and see how we do. Again, you'll want to refer to your perfect square chart that we just did. We've only gone to 20. But I'm going to show you some techniques past there that you can use. If you cannot see any squares that divide the radicand, find the prime factorization of the radicand. All right, so if you look at your chart, the square root of 361, if I go back up, that is a perfect square. That's nice. It's 19. Okay, so we just take it out of the radical and it equals 19. All right, number 2, the square root of 1024. Well, our chart only went to the square root of 20. We're not really using the calculator because we're trying to see how we can come up with these perfect square factors without doing that. All right, so I noticed that it ends in with 24, and I know that 4 is a perfect square factor because the square root of 4 is 2. So 4 goes into 24 6 times, so it's a factor. Okay, so then I might have to then divide and see what's left. Well, how many times does 4 go into 10? It goes in twice. How much is left? 2. How many times does it go into 22? 5. How much is left? 2. 256. Well, let's go up. Is 256 a perfect square? It is. It's 16. So I'm going to rewrite this as 4 times 256. Why? Because I know the square root of 4 is 2. It comes out of the radical. The square root of 256 is 16. And 2 times 16 is 32. So this was 1024 is a perfect square. It was 32. All right, the next one, number 3, positive or negative square root of 100 over 36. So the first thing you really want to do is try to simplify it if possible. But you don't have to because you can simplify it at the end as well. So if you want to just look at it and say, okay, I'm going to take this. I know 36 does not go in evenly to 100, but they might share a common factor. Well, they do. They both share 4 as a common factor. So I'm going to go ahead and divide them by 4. When I do, I'm going to take it, so I have the square root of 25, because 100 divided by 4 is 25, and the square root of 36 is 9. And remember, not the square root of 36, but 36 divided by 4 is 9. They're still under the radical. Now, 25 is a perfect square. It's 5. 9 is a perfect square. It's 3. So my answer is plus or minus 5/3. Now, let me show you how else you could have done this. You could have said, oh, 100's a perfect square. I know that. So that's 10. 36 is a perfect square. I know that. That's 6. But then you can simplify. They're both still divisible by 2. And that's where you still get positive or negative 5/3. So you can do it either way. You might just have to simplify at the end. The square root of 49 hundredths. Okay, so when we talked about it, we said perfect squares are whole numbers. Well, I can rewrite 49 hundredths as 49 over 100. Then I can take, I know the square root of 49 is 7. The square root of 100 is 10. So that's 7/10. So if you want to put it back as a decimal, you can. But 7/10 as a fraction is equivalent to 7/10 as a decimal. All right, and number 5, we have the square root of 64 divided by the square root of 400. I'm going to simplify first. And I know that 16 goes into 64 and it also goes into 400. So that gives me the square root of 4 over the square root of 25. Now I'm going to take the square root of 4. It's a perfect square. 2, the square root of 25. It's a perfect square. It's 5. Okay. In number 6, we have the negative square root of 48 over 75. Well, neither of those are perfect squares, so I can't just take the perfect square of each and then simplify. I'm going to have to see if there's anything I can divide by 48 and 75. Well, 4 plus 8 is 12. That's divisible by 3. And 7 plus 5 is 12. That's divisible by 3. That gives me the negative square root of 16 over 25. 16 is a perfect square. That gives me 4. 25 is a perfect square. That gives me 5. And don't forget the negative that was on the outside. Okay? So that ends up being negative 4/5. All right, I want you to try these 3. I'm going to give you the answers. This one's 35. I'd prefer for you to try to find perfect square factors for that. The square root of 1 and 21/100 is 1 and 1/10, or it can be 11/10, or you can have it as 1 and 1/10 like that. And the square root of 45/500 is 3/10. Okay. So you'll try those, and then let me know if you have any questions on those, and we can go over them. Okay, so now we're going to the next lesson, and this is where they're not just perfect square factors. So we're going to be looking for factors that help us to find perfect square factors. Okay, so for example, the square root of 250. The square root of 250 is not a perfect square, but I do know that 25 times 10 is 250. 25 is a perfect square, so I take that out front. 10 is not. Nor does 10 have any other perfect square factors. That's the other thing you have to think about. If 10 could be broken down to another perfect square factor, then you still have to keep going and taking out perfect squares. But it doesn't. So this just becomes 5 times the square root of 10, and you're done. Okay, this one is 5 times the square root of 32. 32 is not a perfect square factor, but I know that 16 is. So I have 5 times the square root of 16 times 2. 16 is a perfect square factor. It comes out as 4. So now I have 5 times 4 on the outside and the square root of 2 on the inside. There's no other perfect square factors of 2. So this becomes 20 times the square root of 2. 2 times the square root of 288. Okay, so 2 stays on the outside. 288 is not a perfect square factor, but 144 is, times 2. 144, the square root is 12, so this becomes 2 times 12 times the square root of 2, and 2 times 12 is 24, square root of 2. Okay, and number 4, 800, the square root of 882. Okay, well, let's see, I have 8 plus 8 plus 2. And I know 8 plus 8 is 16 plus 2 is 18. Well, I know that 9 is divisible by 18, so I know 9 is a factor. How many times does 9 go into 81? It goes in 9 times. How much is left? 7. How many times does 9 go into 72? 8 times, okay? So now I'm down to 98. So I know this is going to be one of my factors. Not prime, but it's one of my factors. I'm just circling it. I'm going to break down 98 because I know 42 times 9, 49 times 2 is 98. So now I have my 3 factors. So I'm going to break this down to 9 times 49 times 2. 9 is a perfect square, it's 3. 49 is a perfect square, it's 7. 2 is not. So we end up with 21 times the square root of 2. All right. There's about a minute left before we have to stop. I want you to try these, and then we'll come back on and finish up the next part. Number 5 is the square root of 180. Number 6 is 6 times the square root of 800. And number 7 is the square root of 704. Your answers, this one should equal 6 times the square root of 5. Number 6 should equal 120 times the square root of 2. And the square root of 704 should be 8 times the square root of 11. Okay, so that gives you a few minutes to try some, and then we'll come back and finish up this section and some solving.